Anyway, thank you all for coming. And what I'd like to talk about is a system that I've developed for adaptive quizzing for students, and how along the way of trying to create it, what I realized was that there's a whole world of really sophisticated item response theory that is relevant, but it's not directly applicable, and how if you can kind of massage some of these really well-developed tools that are great for one purpose, they can bring a lot of value to this other endeavor, which is teaching and learning. And so I am primarily a teacher. So I teach every quarter at UCLA. I teach large introductory biology classes. And one of the things that is toughest for me, this is what my classes look like, and if you're far enough away, they all look the same. But if you move in a little bit closer, they're not, they're different. And they vary a little bit over time. You can see nowadays students are in much higher resolution than they used to be in the old days. But there's a lot of variation from student to student. And that leads to a huge problem that a lot of people don't talk about when you're a teacher, which is, what's my goal? Do I want to move the average up? Seems reasonable. Or do I want fewer students to fail? That's a different type of challenge. Or am I interested in just the top students? Do I want to bring them up? Because we're kind of fooling ourselves if we think, I'm going to do all that at once. My lecture is going to be so charismatic, so amazing, that it's going to work for everyone. And the sad answer to the question here, can we address the needs of all the students equally in class, in the actual in-class situation? The answer is generally going to be no. But that doesn't mean it's not possible. I love technology, and I think it has a real place at times. One of the things that we've done in the past is we say, all right, I have a lot of different students. How am I going to work with the big variety of their ability levels and their investment in time and so on? So we have office hours. We have extra problem-solving sessions I'll do every week. I'll do review sections. They can email me, and I will write back. We've got a course discussion board, on and on and on. All of these things exist because in class, even if you have all the right words, the variety of student ability levels is going to cause them to receive that in different ways and with different effectiveness. So those are all old school inventions that essentially are trying to get at that model of one-on-one tutoring. I hear what you know, and I ask the right question next so that I can lead you through. And it's really effective, but it doesn't scale very well, especially when I have 300 or 400 students in a term. So I look at them, and I'm trying to figure out what are the words that I can say that are going to have the biggest impact on them. And if I can get some insights, we'll see that I can be better, but I still have to recognize that every one of those students is different, and they're going to be more or less prepared to benefit from the things that I'm saying. Now, if you think about computerized adaptive testing, when I first was trying to develop this system that I'll mention later today, PrepU, not coming from the world of education, I was just thinking to myself, well, I've got to post these practice problems for my students online because they want more help. And then I thought, wow, if I post them online, I can have them take the problems online. If I do that, I can figure out how hard they are. I'll get a probability of them getting it right or wrong. And if I do that, then I can figure out how smart they are. Then I can give them problems that are just right for them. And I was so excited that I was inventing item response theory that I was like 40 years late, but I didn't know it. But I still came to it because it made sense. And it was an important thing that I had to come to it on my own, because it turned out that even though a lot of these things that I was doing already existed, they weren't exactly right for my needs. So in adaptive testing, I won't go into it too much. Lots of you know about it, probably more than I do even. But I want to just make the general point that if you are trying to use some tool, some instrument in order to figure out where is it that your students are. In traditional testing, we might have 20 questions, and I've got difficulty levels just ranking them between 1 and 100, and I've got a bunch of students here from, let's say, 50 to 80 if we rank it on a 0 to 100 scale. And assuming that a student gets a question right or wrong based on the difficulty relative to their ability level, then you'd find, okay, everybody is at or above 50, so they all get it correct. On my exam that I'm giving, that's not helpful because I haven't separated my students out at all as a summative assessment tool. I give another one now and I say, because it's a tough question, I can discriminate between these students and the rest of the students. And you go on down the line, each one, I can see a 39 here, they're all gonna get it right, and so on. You go down, and this is our traditional test that we give. At the end, we tally up how many they get right, how many they get wrong, 13, 15, 15, 15, blah, blah, blah. And from those, I don't know the actual student ability. I know how many they got right or wrong, but I don't really know how hard or easy the questions are. And I can rank, this student is at the bottom, this student's at the top, this one's number 2, and then these are all indistinguishable for me. And it took all those. It's also filled with useless questions in terms of discriminating between the students. If this is my goal to use this instrument here for that. In general, most of the questions are not useful, and you have difficulty ranking students with much precision. You don't know where they are. The more you have, too, the more different ranges of ability that you have to be able to cover with your exam. On the other hand, if you give an adaptive test, that's a test where I've got the same students here, but I give them a question, and if they get it right, I give them a harder question halfway up towards the next point. If they get it wrong, I move halfway back down to the next one. They get it wrong, I move halfway back down again, and so on until then they get one right. Then I go down again. I can figure it out. It took 8 questions to figure out what it was. I go on here, this student, you use the same simple algorithm. I figure out what their ability level is. And anywhere between 6 and 8 questions here, I'm able to figure out their ability and their rank with a lot more precision and accuracy than we could before. So we've got this great efficiency. I don't have to use as many items. When it's on a computer, we have the results immediately, which is very helpful. It's also accurate because I can accommodate a whole range of students. I get information from every item, and it's going to be extremely, as I said, precise and accurate. There also are a lot of other interesting things that come from this. We can figure out the item's true difficulty. We can figure out its discriminating power. How good is it at separating out students of very similar ability levels? We can analyze the distractors. We can start to find what are the possible misconceptions that the students have. Everybody seems to always be focused on this distractor. So there's a lot of value in this type of model. And of course we know that. That's why the big ETS is using it for so many high-stakes tests. It's really good at being a summative exam and giving us this precise and accurate measure of where the students are. The problem is, as a teacher, and not as a big testing agency, or not as an admissions department for a school, my goals are more complicated. I want to engage the students for the entire term. I want them to actually learn. I want their student ability level. One of the assumptions of item response theory is that this is fixed, which seems very anti-intellectual, right? I want it to move. I want them to learn more. I want them to know more at the end. So it's not exactly right for me. So this is where I see this intersection between what we can get from item response theory models and computerized adaptive tests to move them into a learning environment. Here's an email that if you teach college, you certainly get this email. If you're a high school teacher, you get it in person maybe. I included all of it just because the first paragraph is very nice and says they like the class, blah, 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 blah. But then we get down here. I just have a question about my grade on the midterm. I promise I said everything before it was genuine. I was truly surprised to see my grade. We've all heard this before. I talked to a friend in the class. He was also confused. We studied so much. I really understood the material. And yet somehow I was surprised to see my grade. Now, we can take them at their word. This actually is true. They might actually have studied really hard. The problem here is that in many cases, the students have never been taught how to study, or they haven't been given sufficient resources, so they do the reading. Then they reread it, then they outline it, then they highlight their notes, they might watch lecture videos, they can see me speak about it again, then they read some more. They haven't actually ever learned to do the thing that they're going to be assessed on, which is to write about biology or answer questions about biology. They've done a bunch of passive stuff. And then in this high-stakes situation where I've given them this exam, they find out, whoa, this is a wake-up call. But it's a wake-up call that's too late because now they know they haven't mastered the material. In fact, they've confused recognition with mastery in many cases. So if I want to help these students, these massive students, and I can't hit all of them perfectly during lecture, you want to spend intensive time with every one of them. But if you do the numbers, 10 minutes per student, 300 students, that's 3,000 minutes per week maybe, and I'm only giving them 10 minutes, and that's if I line them up outside the office. You want to assess exactly what are their strengths and weaknesses so that you can focus on the specific things that are going to help them. You don't want to waste their time with something they already know. Figure out what they need, then give them the tutoring on that thing. Evaluate their progress. Are they learning? Are they moving forward? You want to move into their house with them so that you're there all the time. And eventually, you're going to be able to help all the students to get to some next level. That's my goal as a teacher, is that every student, they're going to start out in different places. They're going to end in different places. I want the slope of the line to be maximal. So to move them from this recognition to mastery, if we assign a bunch of low-stakes assessments online, so it's easy, they get quick feedback, and they can do it on their own time. You give feedback, you give targeted remediation, if possible. That's not even essential, but it's helpful. Follow up with additional assessments so they can see where they are, they can follow themselves as they move through. What you can do essentially is take the parts where the students vary from each other, move it out of the classroom so that they have a tool for getting to the level they need to be. The things you need are these. You need an engine that's going to analyze, are they getting them right, are they getting them wrong? Not that hard to do, not different from anything in computerized adaptive testing. You want to know how hard the questions are. There are other things. You want to know the topics so you get the proper spread and so on. You need the analysis engine that's going to figure out your student's ability level. What's the average difficulty of the questions that they're getting correct? But here's where you have to change then. You need some algorithm that's going to help you to deliver the right question at the right time. If you're given a computerized adaptive test, that is the question that is most quickly going to allow you to home in on their true ability level. When I'm a teacher, that's not it. I want them to move up. So it's different. And the models don't say, here's what you should do. So what you have to think about is, what's the most helpful next question? What is the most helpful instrument? One quiz at a time. So you have to come up with essentially a distribution. And this is your optimal distribution of questions. You put them into a bin prior to the quiz. And if their level on a subject is 35, you want to be at 30 up to about 50, but you have to choose where do you want them to fall exactly, and that's a constantly moving distribution around the students, and it can be, depending on how well you can meta tag your items, it can be individualized for all the different topics. So you're using the measures from item response theory, but you're using them now in a different way to move the students along, to violate that assumption that student ability doesn't change. Targeted remediation links to resources. At the end, you show them, here's the question, here's how you did, here's what you got right, here's what you got wrong. It's very helpful so that they can get to that content in a way that will help them. And one of the things that is super important is that this will show you, if you have an item that has very low discrimination, it's a bad item. If you're ETS, you throw it out and you buy new items. If you're me and writing items is so difficult, you figure out, why is it not performing? How can I change it? You throw it back in and you fix it. But you look at the distractors and you figure out what's going on. All right, it's a really hard question. Everybody who's getting it wrong is clustered around this one wrong answer. That might identify a misconception. So now what you can use from these analytics, I can sort my 10,000 biology questions according to their misconception index. And I can say, hey, these are things that might potentially be useful teachable moments in class. Because now I know I'm looking at my class and I'm able to see their performance on them. I'm able to see which questions are maybe going to be most useful. Now, when I give this to my students, I call Prep U. This is a data showing how much do they use it. This was in a class where they didn't get any credit for it. The average number of questions, 917. Guess what these days are focused around? Those are the 2 midterms, that's the final. With their limited time, that's what they chose to work on. This is another class. I can sort my students by how many times. Some of them are answering thousands of questions, but the average was more than 1,600. So they choose to use this. And the other thing is, I've done some efficacy studies using GRE, MCAT, California State Standards questions, and looking at before class and midway through the class, if they were using this, they actually perform better. And the comparison here isn't with the students who just didn't have Prep U, it's the students who didn't have it, but when they did have it later in the term, they used it significantly, same amount as those students. It's helpful. So I'll close with my take-home message is, if you have these low stakes and outside of class assessments, they can give the students a wake-up call, they can help them with their retrieval practices, get them good at doing the thing that they're going to be required to do. When they're adaptive, the students stay more engaged. The questions aren't boring, the questions aren't tedious, they feel like it's a high hit rate of challenging questions rather than a static generic test bank. And I like to think of it as slow speed formative assessment, because as a teacher, when I ask a question in class and someone doesn't quite get it, or if I have the students, if I use clickers, answer something and I'm getting information, it's not always possible to immediately alter your course in the appropriate way. This way it's slow speed because they're using it all the time. I look online the night before. I look online right before class and I say, here's where they're going wrong. I could use this question. And so it allows me not to have to think on the spot quite so much. I get a little bit nervous during lecture, and I like being able to come up with that in class. So I will stop here. So it's sort of my abomination of item response theory to serve a slightly different goal.